All right. So I got the notification that we're streaming. It says College Algebra. I'm going to assume I haven't made any changes, so it should be working. So I'm going to let that be. I'm assuming that it is working. So welcome. It's a Good Friday. Do I have any math jokes? I don't have any offhand. I don't have anything really. I can't think of anything. You got one? You got plans to give Mr. Piper? I don't know any, and I should. I don't study it. So if you all can bring it, I know you can guilt me. This is me. I don't feel bad about who I am anymore. So you can guilt me all you want. But bring that. I would appreciate some information like that if you wanted to bring that in every day. So today is Friday though. So happy Friday. I do intend on getting out in the weather. It's been fantastic weather these past few days. I went and ran like 10 miles the other day. Awesome. So, yeah. Well, I just went on foot 10 miles, like 5 miles out, and then went back home. But it's nice. So I plan on getting out of today. I probably might go to like Sweetwater Creek or something like that, be near the water, sun, water, all this kind of jazz. Okay. So now today, we only have really a solid hour, a little bit beyond. So I want to spend about 30 or 40 minutes per section. I'll do as many examples as I can. I'm going to have to leave a lot of it as an exercise. Somebody has some food that smells fantastic.
I made it.
It's not the chips, though. It smells like hot food. Oh, yeah, okay. See, I didn't see. It was hidden by the chip bag. Yeah, it smells fantastic. What is it? Yep, that's exactly what it is.
What is it?
It smells awesome. Now I'm going to be salivating the whole time. But yeah, so we have about 30 or 40 minutes per section. We have 2 sections we need to go through. Now, the first order of business, so for the second phase of access to my math lab, what our workaround is going to be, I'm going back to my original technique of using a dummy email. So what I did is I deleted it and started from scratch, and I loaded it. So the PDF on how to access it is in our Moodle page. So if you go to our Moodle page into the announcements, there's a PDF that tells you how to register. All you're going to do is follow those instructions, register as a new student. So you're going to use a second email. And then you should be prompted to get 2 weeks of free access, and that's what we're going to use for the next couple of weeks. If we were paying, we wouldn't have to do this, but we're not paying, so this is what we have to do for right now. So that's the first order of business. You definitely want to make sure that you have access to My Math Lab. It's a very powerful tool. On My Math Lab, there's already a study guide that's been loaded for exam 2. I will say that if you know my study guide, you should be okay for the exam. If you're comfortable with every question on the study guide, you should be okay for the exam. Okay? So you work that however you want. There is a PDF version of the study guide loaded into our shared box folder. Also, the instructions for My Math Lab are also in the box folder as well. Okay? So let's kind of go through what we need to today. If you need help on registering or access anything, just let me know. The reason I suggest My Math Lab is the same information as the PDF. And it explains how to do each and every question. If anything is not clear, you have some very powerful tools and aids there to assist. So if you know our shared box folder, you see the 5 folders for box. You got the syllabus, notes, so walk her through it. It's the study guide is in the study guide section, and the PDF is in the handout section. So it's 2 different folders inside our box, but they're both there. Okay. But yeah. So as you're going through the study guide, if anything is not clear, especially if you're working on My Math Lab, they have the thing called View an Example, and it explains how to do each and every question. So come Monday, the only reason you really wouldn't be proficient on any question that's on the study guide is you just didn't take it. You didn't prioritize it. But if you really want to know how to do each and every question there, it's all there waiting for you to take it. So yeah, and if the computer's explanation on how to work these questions doesn't suffice, there is a tool on My Math Lab that says Ask My Instructor. You click it, and it'll send me a snapshot of whatever question you're working on My Math Lab. It'll come directly to my email, and I'll pull myself to the side, and I'll make a dedicated YouTube video. Yeah, this is what I've been trying to get you all to take advantage of the whole while. But yeah, so you send me a snapshot it'll send me a snapshot of what you're working on. And then I can go at a completely slower and completely different pace on YouTube. I can take my time, go step by step, and then you'll get a video copy of it, and you can pause, rewind, do whatever you need to do for it to sink in, and you'll have it's a video log of all these kind of questions. So just take advantage of it, and it's a powerful tool. Again, I'm proficient at least from Calculus 3 on down. So even if you were taking like pre-cal or calculus or anything of that nature, and a few classes beyond Cal 3. It's free tutoring. As long as you use this service, it's free. They don't charge me anything to do it, so I don't mind offering it for free. That's just if it floats your boat or it speaks to your prerogative. But aside from that, the information is there. Information is there, and the exam is Monday. Okay. Any questions, comments, or concerns before I jump into the material? Going once, going twice. Go ahead. I forgot what it was, but it was about the test. Mm-hmm. No. Okay. Would you recommend focusing on the homework or the study guide? It should be the same material. If it's not, the study guide takes precedent. The study guide first. You want to be comfortable with everything there first. And then beyond the study guide, keep practicing with the homework. This is all about repetition. So study guide is the priority right now. Exam is Monday. And then once you're comfortable with the study guide, keep working the homework. Yeah, keep working the homework. So again, I'm just only doing that because we're on the quarter system and it's a little rushed. But you do have to be careful. You saw with the first exam, it's not always a guarantee. But I'm saying as your instructor, the order of priority, once I do release study guides, you definitely want to be sure to be comfortable with everything at a minimum. Know that first, and then the homework. Okay, I'm going to move forward into the material. Any other questions, comments, or concerns before I go forward? All right. What's your plan this weekend? So at least one of two things, either Uber and Lyft or being in nature and exercise, run around, that kind of jazz. I love nature. I love it. No matter what I'm going through, it always helps. All right. Oh, the thing? Yeah, I'm ready. So, okay. So we're moving into section 1.7, inequalities. I'm watching the clock, so we'll work this until about 12:30, give or take a few minutes, and then I'm going to move on to 1.8. So I'll do as many examples as I can. A lot of it's going to be an exercise for you. After today, if anything is not clear, again, you can email me, and I can continue more videos if you need me to. Okay. So properties of inequality, let A, B, and C represent real numbers. If A is less than B, then we can add the same real number on either side of the inequality and preserve the inequality. So that first line is saying, okay, give me a color. Green. Just for the sake of time, I'm just going to do an arrow today. No interest in images. Yeah. Okay. Oh, that hurts my feelings. Okay. It's all good. All right, so now here where it says less than, this can also be greater than. This can also be less than or equal to. This can also be greater than or equal to, okay? So just have to be consistent. So if you're applying this property, it has to be consistent throughout. And the second one, again, this applies for any of the inequalities. If A is less than B and if C is positive, then we can multiply the same positive on either side and preserve the inequality. But if A is less than B and C is negative, what happens when we multiply an inequality by a negative? What happens? It flips, okay? So if we multiply or divide by a negative, the inequality flips. Any questions, comments, or concerns there? Okay. Everybody print their name on the attendance. 2, 4, 6. Let's do this. 2, 4, 6, 8, 10, 12, 13. Okay. It's looking good. All right, so I'm moving forward. This is 7, 1.7. So let's look at motion problems. So multiplication may be replaced by division for properties 2 and 3. So in properties 2 and 3, we multiplied, on either side with those numbers, and we had those effects. Multiplication in this context is going to be the same as division, except we can't divide by what number? We cannot divide by 0, so it doesn't hold for dividing by 0. Always remember to reverse the direction of the inequality when multiplying or dividing by a negative number. And again, we don't divide by 0. So linear inequality in one variable. A linear inequality in one variable is one that can be written in this form. What does this remind you of? When we say linear, mx. Yeah, y equals mx plus b, right? What's the m in this case? A, the slope, right? And then what's the b in this case? B. What does the b represent? The y-intercept. What is the y-intercept where it intercepts the y-axis? Where it intercepts the y-axis. Yeah, that's right. That's fine. Just making sure. Now, so where A and B are real numbers and A is not 0, and any of the symbols can also be substituted for the one that you see. This is relating a linear equation to inequalities. But the same properties hold. Yeah, the same properties hold. It's just we're going to take those baseline axioms or properties and then keep building on those. So if you miss anything, it can get a little bit dicey. So just kind of, I might just use what's there. Now, if we're going to solve these inequalities, all we do is we treat them like an equation. You solve it like an equation. I actually want to do a demo on this one. Let me go ahead and do it right now. So we're going to bookmark this one. There you go. You know what's about to happen. I want to copy this. I would like to paste it here. Come on. All right, so I want a copy of this. That's fine. So ladies, again, in the back, the chatter is distracting me. I don't mind now. Okay, so rules engagement for my courses, I don't really mind technology. I don't mind if you text each other, things of that nature. As long as it's silent and I can't hear it and it's not distracting me, I don't make a big deal about it. But the audio, I'm listening, and so I'm constantly trying to tune it out so that I can focus. So I'll just sit there to say, just minimize the chatter so that I'm not, I don't single you out in that kind of light. Okay, so now, to keep it as simple as possible. Now, if we're going to solve this, the first thing I would suggest, treat it like an equation. If this were an equation, what would you do first? You can keep the color. Okay, so imagine that inequality is an equal sign. What would you do? Subtract 5, right? Okay, that's okay. That's okay. So if let's do this. Let's do this color. We're going to say minus 5 on either side. All right. 1, 7. So then we'll get negative 3x greater than negative 7 plus negative 5 is negative 12. Okay. So then what? Okay. So then if we divide both sides by negative 3, okay, so then what do we have to account for? What happens? It flips, right? Because we multiplied or divided by negative, so the inequality flips. Then x is going to be less than, what is that number? Positive 4, right? So then now, this is what we got in an algebraic sense. What is this? What's this in interval notation? Are we talking about all the numbers above 4 or all the numbers below 4? The alligator's eating the bigger thing. Which is bigger? Our numbers or the 4? The 4 is bigger. So everything below. Does that make sense? It takes a little bit of practice. Yeah. Yeah. So the alligator's going to eat the bigger thing. The alligator's eating the 4. So that means our numbers are smaller than 4. So when we go to graph it, right?
So when you say our numbers, you mean X.
Well, yeah. X, right. Exactly. Come on. So yeah. So when we graph this, we're only concerned with 4.
Oh, the number line thing.
The number line thing, yep. Positive x goes this way. Are we talking about numbers to the right of 4 or to the left of 4? Left of 4. Now, there are 2 correct answers here that I'll accept. So we are talking about the numbers to the left, right? What kind of symbol goes on the 4? There are 2 correct answers I'll accept.
It's a dark circle and an open circle.
Okay, so between dark and open, which one is it?
I think it's this one.
Okay, so this one is going to be open. I'll accept open. I would also accept this one as well. This one's also correct. These both mean the same thing. It's a parentheses.
Oh, that's it.
Okay? So the parentheses is the way the book does it. Open is might be what you'd be more familiar with. Now, can anybody explain to me why is it open versus closed?
Because everything less than it.
Is it equal to
When it's equal or less.
Yeah, the equal, right? If this bar were here, then this would be filled in. Right? If that bar was there, then it would be a closed circle, and this would be a square like that. Square bracket. But it's not, so we're going to get rid of this one, that one, and that one. And this one is strictly less than 4. But parentheses, did I say I didn't copy it? I'll just draw another one.
Okay, so I'm sorry. The closed circle is the one that's
So
equal to.
So hold on. So watch. So copy. Okay. So notice there's no bar under here. So if you have to watch the screen, there's no bar here. What this symbol means is that we get really, really close to 4, but we never reach it. That's what the parentheses means. We get really, really close to that number, but we never reach it. All right? We get really, really, infinitesimally small. We get really, really close to 4, but the parentheses means we don't include that endpoint. The circle means the same thing. We're going to see an example where it's closed in. So let's just kind of pause for the cause. Yeah. Remember that when I had the purple stuff there? We're going to see an example where that pops up. Okay, let me move. Okay, so now, if either of these graphs are acceptable, what's the time? I'm watching the clock. Okay, we only got about 20 minutes left, and we got a good ways to go. So now, if these graphs are proper, how can we check something like this? So I'm going to copy. Let me get a copy of this. I just want this stuff. I want to copy. I want to paste, and I want this to go here. So our claim is that the graph of this inequality is this. Either one of these. I'll put it down here. That's fine. So now, how can we check that this is correct?
Plug it in.
Plug what in? Okay. If we plug in 4, will it make it true or will it make it false in this context? In this context, this is saying that x cannot be equal to 4. So if we plug 4 in, it should be false. Let's look at the original. What's 4 times negative 3? What's negative 12 plus 5? Is negative 7 strictly bigger than negative 7? No, right? Which is what we anticipated. Now, so 4 should make it false, and it did. Give me a number that should make it true.
Negative 3.
What's the easiest number that we can plug in to test? Even easier. 0, right? Because 0 right now is like right here, right? So
it's less than 4.
yeah. So we can plug in 0 and it should work. What's negative 3 times 0? 0 plus 5. Is 5 bigger than negative 7? So that's true. What's the highest integer? What's the highest integer that's going to make it true? There's an infinite number of numbers that can make it true. What's the highest integer that we can plug in to make it true?
3.9.
Integer. 3, right? The highest integer that we can plug in to make it true is 3. So if we plug in 3, negative 3 times 3 is negative 9. Negative 9 plus 5.
14. Negative 4. No. 5. Negative 5.
Negative 4, right? Which is bigger, negative 4 or negative 7? Which is further to the right?
Negative 4.
So that's true. Negative 4 is indeed bigger than negative 7. Does that make sense? Okay. So again, okay. So now, if this is the graph, could you tell me how do we write the solution in interval notation? If we read the graph, how far left does the graph go? Left. Not infinity, but negative infinity. So the far left is going to be negative infinity. How far right does it go? 4. 4, right? It goes up to 4. Infinity always gets what symbol? What's that? What kind of grouping symbol? Okay, yeah, it always gets a parentheses, right? If infinity always gets the symbol.
This is called a what? What are we writing?
This is called the inequality, this part. What symbol in this case does the 4 get based on the graph? Another parentheses, right? Okay, we're going to explore some of the different options. So these are the 3 different ways to express that solution. This is actually good. And, okay, so this is fair game that could pop up, stuff like this. Okay, let's just do another example. We checked it. We got the set notation, the graph, and the interval notation. So then we can scroll ahead. We get the same result. And that's all just saying stuff that we're going to experience. Okay. Let me do one more, and then I'm going to start using what's already there. So let me paste. Nope, can't have it. Let's copy. I'm going to paste right here. And this page, I would like to clear it. Clear the page. Let's copy that page. And then we would like a copy of this example. We can highlight that. That's fine. Let's work another example really quickly. We're almost out of time for this section, so you're going to have your work cut out for you. Again, if anything is not clear, I could do dedicated YouTube videos that I can load later. We don't really have a lot of time. It's just a lot of information with a little bit of time. This is why I don't mind open notes for this course, for this structure, because it's jammed. So that could be a blessing or a curse. It depends on you on how it comes about. Okay, let's try this example. We have example 2. So we're actually solve and then give the solution set in interval notation. So let's do the same thing. Give me a color. Got her purple. So here's the original. 4 minus 3x less than or equal to 7 plus 2x. Now again, initially, for right now, imagine it's an equal sign. If it were an equal sign, what would you do? Okay, so isolate the variables. We're going to get the variables on one side and then everything else on the other, right? So how are we going to do this? Okay, we can subtract 4. Let's move the variable first. Which variable? The 2? Okay, that's fine. We can do that. Let's go ahead and subtract the 2 from both sides. I'm just going to go ahead and move the 4 because I know that's what I want to move. So I'm kind of skipping some steps. This is going to cancel. That's going to cancel. On the left, what happens? Negative 5, right? Less than or equal to 7 minus 4 is 3, okay? So far, so good, right? What's the next move? Okay, what happens? Okay, the inequality flips again because we are dividing by a negative. Okay, so then we get this negative 3 by 5. Now, if this is a solution, what does the graph look like? So we're only concerned with negative 3/5. That's the only number we really need. Now, are we talking about the numbers on the right side or the left side of the negative 3/5? Which is bigger? X X or the 3/5? What is the alligator eating? Alligator's eating the X, alligator's eating the bigger thing. So then are the numbers on the right or the left? The right. The bigger numbers go to the right on the number line. So when we graph this, we are talking about the numbers going this way. Okay. So then the next question is, what kind of grouping symbol? What'd you say?
I was going to say use the little bracket.
Square bracket. Why is it the square bracket? Because of the equal to. So this is all good. So this is going to be a square bracket. Square bracket is the same as the closed circle. Both of those are acceptable. They're both acceptable. So either one. Okay, so this graph is good. Now that we've graphed it properly, tell me the interval notation. How are we going to write this in interval notation? So how far left does the graph go? To the left. Based on the drawing. So, okay, let's do it like this. So look, we're here, right? So if we go to the left, where does it stop? Negative 3/5, right? So then the far left, it goes down to negative 3/5. How far right does it go? Positive infinity. Infinity always gets what grouping symbol? Parentheses. Keep in mind, all the stuff you see me writing, I will load it into box. Oh, it's fine. It's fine. I'm just saying it just for everybody. Keep in mind, I do load a copy of all of this to box, and anybody, like the students here and the students at my other location, you all have access to this information. So once I'm done, I plan on loading this before I walk out of the room. What kind of grouping symbol does a negative 3/5 get? Square bracket, right? Okay, so these are the solutions. Let's do like this. I just kind of want to... Because it could be equal to. The square bracket means not only does it get really, really close to that number, but it can also be equal to that number. Yeah, these are fantastic questions. Again, my philosophy is the only dumb question is the one not asked. So if you have it, ask it. Actually, I'm going to leave it here just for this environment. Now, in the everyday life, that might not apply. Because sometimes people definitely be trolling and trying to waste your time. But here, that happens too, but that's my job to kind of regulate all that stuff. So don't worry about that. Okay, now, we got these results. How can we confirm them? Like, say this is an exam. How can we confirm whether these are to the best of our ability? How can we confirm these results? Plug it in. Now, what is it? Well, okay, yeah, we could plug in the negative 3/5. If we plug in the negative 3/5, should it be true or should it be false? Can it be equal to negative 3/5? Yeah, so it should be true, right? If let's do it. So I'm gonna go here to my trusty dusty rusty. Yeah, I do that just I don't know. I don't know. My mind goes there, so I just say it and I keep it moving. All right, I'm giving you all a window into my mind. Okay, so now I'm gonna write the original. If we plug the negative 3/5 in, say I said, let me see, I'm trying to think of how to check it. So in order for it to be true, the left has to be smaller than the right, less than or equal to the right, right? I'm probably going to do, if the left is smaller than the right, there's a number of ways I can do it. What I'm going to do, I'm going to say the right minus the left. If the right side is bigger, and I say the right minus the left, what kind of number should I anticipate?
Say that one more time.
If the right side is bigger, and we say the right side minus the left side, what kind of number should we anticipate?
A smaller number than the right side.
How small?
What, like negative or something?
Right.
Decimal?
Right. How small are we talking? Like what kind of number? Positive, negative, or zero?
There might be zero.
So if the right is bigger, okay, that might be
Equal to.
well, in this case, it should be equal because it's going to work out that way. But when we want to test out the numbers,
If
So scratch that idea. I think that's a bit of a stretch. What I'm going to do, I'm just going to plug this into the original. We just need to confirm that the left is going to be indeed less than or equal to the right. Okay. So what I'm going to do, I'm going to go to y equals. I'm going to say 7 plus 2x is my first one, and then the second one. Actually, let's do 4 minus 3x is the first one, and then we're going to say 7 plus 2x. We're going to say 7 plus 2x is the second one. Then I'm going to quit. I'm going to go to variables, y variables. The first one. Now, let's plug in. We said we're going to choose negative 3/5. Okay, we get an answer. Let's plug it into the right. I'm going to go to variables, y variables. Now I'm going to try 2. Sorry. When I do the second one, we plug in the negative 3/5. What kind of answer should we get? Bigger than or equal to. Is that number bigger than or equal to? Yes. Okay. Give us what's another number that we can test that should make it true? What's a number big? What's easy? What's an easier number that's bigger that we can test? Even easier. 0, right? Is 0 bigger than? Is it to the right? It is to the right. So when we plug 0 into the original, it should make it true. So let's go back to the first one. Just here. I'm going to plug in 0. Delete, 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 and I'm going to say 0. Now we're going to get an answer. We got an answer. Let's plug in 0 into the second one. What kind of answer should we get? Bigger than or equal to? Let's see. Is it bigger than or equal to? Okay, so that checked out. Now, really quickly, give me a number that should make it false. What's the number to the left of this set? So if we're at a negative 3/5, what's the number to the left? Okay, negative 1 is to the left. So let's try. So when we plug in negative 1 into the original, it should make it false. All right. So if we plug in negative 1, we get an answer. And then let's plug it into the second one. Now, if this is going to be false, what kind of result should we anticipate? Something that's not less than or equal to, right? So let's see. So it should be something. Yeah, it should be greater than or equal to. Sorry, it should be strictly greater than 7, right? Let's see. Did we do it? Let me see. Hang on. Give me a second. Negative 1. Unless we. See, if this is wrong, 7 looks good. That's the left, right? Yeah. Yeah, that's right. This is right. Because what we're saying, when we plug negative 1 in on the left, we got 7. When we plugged it in on the right, we got 5. Is 7 less than or equal to 5? No, which is what we anticipated, right? That's what we anticipated. Does that make sense? I think I said the wrong thing at one point. I had to come back and clean it up. Okay, that was me. No, that was me. Just kind of got a little twisted. But you see how to check the inequalities. You kind of got to do a pick a point or test a few different points to test it out. Okay, I'm going to keep moving. Now, we only got about 5 minutes before we hit our 30-minute mark. I'm probably going to do one more example, and that might be the end of 1-6. Okay? 1-7. I'm going to move into 1-8. Yeah, so the exam is Monday. So yeah, we're trying to get two sections in today, because we just don't have the time in class to really go through everything that we need to. So we did this one. We got x. Now let me see. We got x is greater than or equal to negative 3/5. I think they got the same thing and the same interval notation. Okay. Okay, let's look at this example. So find the break-even point. It says if the revenue and cost of a certain product are given by these functions, where x is the number of units produced and sold, at what production level does R at least equal to C? So we want the revenue to be what? Equal to or greater than, because the revenue is the money generated from this experiment or whatever. The C is the cost. So you want the revenue to be greater than or equal to the cost. When the revenue is equal to the cost, we call it the break-even point. It's like even Stevens. So it's like, yeah, so you kind of break even. But you really want to find out what does it take to maximize the revenue or maximize the profit, should I say. You want the revenue to be greater than the cost, okay? So what we're going to do, we want to look at when is R, we want it to be greater than or equal to the cost, right? So then we're going to say 4x needs to be greater than or equal to, what is that, 2x plus 1,000, right? So if we solve, what? Subtract 2x, we get 2x greater than or equal to 1,000. Then what? So then x is greater than or equal to 500, right? So it seems like as long as we, so it says at what production level does R need to at least equal C? So give me 1 second. It seems like, give me just a second. It's okay. It seems like if we produce at least 500, produce and sell at least 500 of these units, and right at 500, the revenue is going to equal the cost, and then above 500, we should start to exceed the cost as far as production and selling. Does that make sense? Does it make sense? So revenue is the amount of money we generate. Cost is whatever is going down to run this operation. So we want the revenue to be greater than or equal to the cost, right? We have an expression for the revenue, right? We have an expression for the cost. So we just say R is greater than or equal to C. We substitute those expressions in right there. And then from there, you just solve it like an equation. Imagine it's an equation. Subtract 2x from both sides. You get 2x greater than or equal to 1,000. Then you would divide by 2. So we divide by 2, we get this. Right?
No.
No? I made a mistake?
Yes.
Where?
X isn't greater than 500. It's 500 greater than X.
Oh, you saying it needs to flip?
Yeah.
Why?
Because you divided.
Ah.
No,
So where's So where's the error? Yeah, we only flips. Yeah, it only flips when we multiply or divide by a negative. Yeah.
Okay, so I've been doing stuff wrong my whole life.
That's why we're here. That's why we're here in this space and time. Okay. Okay. So this is fine. So this is saying that, and we can check it by plugging into the original and all that kind of jazz. But what this is saying is that we need to produce and sell at least 500 units in order for the revenue to be greater than or equal to the cost. Okay. So you check it, we get these results, and then the rest is the same as before. Let me do one more. I'll do one more, and then we're gonna close out this section. Yeah, let me touch on this one. I'm gonna kind of gloss through the rest of them. I'm gonna work one more. So we should have a copy. So let's paste right there. It's looking good and healthy. We would like a copy of this. And right there, this, and this. Does that. I need that. And then this. And then we're going to drop that right. Come on. Nope. You don't want to behave? You acting up? There we go. All right. So then you're there. Then there. Yeah, it's temperamental. Have to sweet talk it a lot of times to get it to work properly. I love it when people say, "Oh, stupid calculator." I was like, it's just reflecting the energy you're giving it. It's only as good as the user. It doesn't matter what it is. Smartphone, calculator, car, it doesn't matter. It's only as good as the user. So, so when people are, downing their technology, they're really downing themselves. When you down each other, you're really downing yourself. But that's a whole nother level. So, no, it's the truth. It's the truth. But, I'm going to let it be for now. Again, this stuff is the same. It's all the same thing, expressed different ways. Okay, so now let's work this example. Give me a color. Okay, I heard blue. I'm going to just write the original. This, right? This, and this, right? So now, right now, we're going to imagine that each of these inequalities, we're just going to imagine they're equal signs. You can break them apart and work into two different sections. We can do it all at once. So whatever we do to the middle, we do to all three parts, right? Okay? So what's the first thing you would do? Subtract the 5, okay? So if we subtract the 5 from the middle, we do to all three parts, and we get the following kind of result. That goes to 0. What's a negative 2 minus 5? That's negative 7. This just comes down. The 3x comes down. This comes down. What's 2 minus 5? Try again. Sorry. 20 minus 5, 15. I was speaking faster than I'm thinking. Okay, so now if we're at this point, what would you do next if you just had 2? Divide by 3. So what we do in the middle, we do to all three parts. So then we get a result like this. We get negative 7 by 3. This is x, and this is what? 5, right? So now, if we get this this result, what does the graph of this look like? So the graph, we're only concerned with the negative 7 by 3 and the 5, so we put it in order. Okay, I see that. Now, this is saying that x is strictly bigger than negative 7 by 3 and strictly smaller than 5. So are we talking about the numbers on the left? Okay, so see that these 2 points break the number line up into 3 segments. We got the first, we got the middle, and we got the last, right? So is our x, is it in section 1 and or 2 and or 3? It's only in section 2, right? So we're saying that we're going to go from here to here, right? Let's kind of clean that up a bit. Because we didn't multiply or divide by a negative. It only flips when we multiply or divide by a negative. Okay? So now, we got a question on the grouping symbols. Tell me about the grouping symbols. I heard 2 parentheses. Does that make sense? You can either do 2 parentheses or 2 open circles. They're the same thing, right? I prefer the open circles as well, but when you master doing the parentheses and square bracket, it's easy to go to the interval notation. So that's the only reason I kind of push it. And that's the way the book does it, so that way you can kind of be aware. All right, so now, we got the set notation, we got the graph. Tell me about the interval notation. What's the far left? Okay, so far left is negative 7 by 3 up to 5. And tell me about the grouping symbols. Any questions there? Go ahead.
Okay, yeah, I get it.
Okay.
You have the one that's the loose and one that's the
Right, and those are like the endpoints. And then, so now how can we check these results? You always want to. Again, in math, when you get on the exam and you get to your answer, what you're saying, if you don't check, what you're saying is, oh, I've been in school for, what grade you guys in? 9, 10, 10, 11? So it's like, so it's 12th grade, 12. Okay, so so when you get on a math exam and you don't check your work, especially when you can check it, what you're saying is, oh, I've been in school for 10 or more years. This answer may or may not be right. I'm going to leave it to chance. I'm going to say I don't care. I'm going to leave it to chance. So when you don't check your work, that's what you're saying. But when you check it, again, chance favors a prepared mind. If you want to boost the odds of just sheer luck being in your favor, you definitely want to check your work, okay? Cross all your T's, dot your I's. Whenever possible, check. You don't always have that luxury, but again, that's what made me fall in love with mathematics. So here, I see that 0 should be in the solution set. If we plug 0 into the original, it should make it true. If we plug 0 into the original, it should make it true. Let's see what happens. What's 3 times 0?
0.
Plus 5 is 5, right? Is 5 strictly bigger than negative 2? Yes. Is 5 strictly less than 20? Yes.
Oh, that's
okay.
Really all you have to do because you just got to plug in for X.
Right. Okay.
Oh.
Give me a number that should make it false. 7. Okay, that's true. So now, if we plug 7 into the original, it should make it false. 7 times 3 plus 5 is 26 strictly bigger than negative 2? Yes. Is 26 strictly less than 20? No. So that means that 7 is indeed false, is what we anticipated. It checks out. Does that make sense?
I feel a little smart today.
Okay. So again, if it don't make dollars unless it makes sense. If it don't make sense, it don't make dollars. You know, kind of deal.
Can't you just plug 7 into the negative that equation at the bottom?
So the drawback about plugging it into the bottom is that if we made a mistake and we're checking based on an error, then we could be led astray. So that's why we always go back to the original, the least amount of manipulations as possible. The more manipulations we do, the greater the chance that we can make a mistake. Yeah. And again, the odds of success are boosted by repetition and our skill level. But, you know. Okay, these are great questions. We're kind of out of time for this section. I'm going to kind of scroll through the remaining slides and mention anything I see as pertinent. We got the parentheses, so we got that one fully. Quadratic inequalities. Now, as far as I'm concerned, the best way to solve these, if you can graph the quadratic, I don't know that we've talked about that or not. I'm kind of drawing a blank. But if you can graph the quadratic, that tells you a lot about the inequality. To me, look, as far as when it's quadratics, it's easiest just to look at the graph. That's the simple explanation. I'll let you go through this on your own. There's a whole other technique going on. It's pretty much a pick-a-point method. I really need to do a demo on it, and I might later. Now, this is basically saying, when is this quadratic below the x-axis, right? So if you were to factor this, just really quickly, if we factor this, what are the x-intercepts?
X.
We're looking for two numbers. Give me a color. I heard red. So we're looking for two numbers that do what? Multiply to give us what? And add to give us negative 1. What are those two numbers? It's negative 4 and positive 3, right? Negative 4 times 3 is negative 12. Negative 4 plus negative 3 is negative 1. So then, what are the x-intercepts then? Try again. 4 and negative 3, right? So it should cross the x-axis at negative 3 and 4, right? Which way does this parabola open? Does it open up or does it open down? It opens up because the leading coefficient is positive, right? The leading coefficient is positive, so it opens up. Now, so we have a U-shaped graph that opens up. It crosses the x-axis on the left at negative 3. It dips, and then it crosses the x-axis on the right at 4. Again, this is where the power of a graphing calculator will come in handy. You could just graph it and look at it. So the question is asking us, when is this U-shaped graph below the x-axis? Again, I'm interpreting what this means. This is saying, hey, when is the graph of this below 0? In other words, when is this below the x-axis? Well, if it opens up and it crosses the x-axis here, when is it below? Between negative 3 and 4. Does that make sense? If you look at the graph, for quadratics, this makes it drastically easier. The book does it a different way. They're going to do a pick-a-point method, and that's fine. But the easiest, simplest way to synthesize this, look at the graph. This is saying, hey, when is this below the x-axis? Okay? So if you graph this, right, you're going to have a U-shaped graph. It's going to be something like this, right? It's going to be like this, where this is negative 3. This is going to be 4. So when is it below the x-axis? Here's the x-axis right here. When is it below the x-axis? Oh, between negative 3 and 4. So the solution should be from negative 3 to 4. Can you tell me about grouping symbols? Okay, it is parentheses. Why is it parentheses? No bar. No bar, okay? So it should be like this. And then just check and make sure that should be the result. You can check and test. That's an oversimplified quick explanation on quadratics inequalities, okay? That should be the result. Let's see. Let's keep going and check. So they're doing a pick-a-point method. The graph is essentially doing the same thing. It's what's going on here. That's a different one. Right there, negative 3 to 4, okay? Now, the book does it a little bit different. They're going to still get those x-intercepts, and they're going to choose points on all the 3 segments and then check the y value. When you kind of synthesize what they're doing and compare it to the way we did it here, you'll start to see the nuances, okay? Only way you're going to see the nuances is by practice and repetition. We are completely out of time for this segment. So just, if you have any questions, just write them down. Let me kind of finish my yammer, and then I'll entertain questions at the end. So this one, okay, just at a quick glance, if we try the same technique, notice it is quadratic. Which way does the quadratic open?
It's up.
Yeah, because the leading coefficient is positive, right? So the quadratic should open up. I don't know that we can quickly factor this. I'm going to try really quickly, see if I can factor. Let's see. 2 times 12 is what?
Negative 24.
Negative 24. Two numbers that multiply to give us negative 24 and add to give us 5. Let's go down the list. 1 and 24, that's a no. 2 and what? 12, that's 10, so that's no. I'm going to continue here. Can we do 3?
3 and 8.
So negative 3 and 8 is negative 24. And these are the two numbers we're looking for. So if we did the box method to factor, I'm just trying to be quick. We got our 2x, come on, 2x squared. We got our negative 12 here. We said, let's change this color to, let's go here. So those numbers go here. We're going to say negative 3x, and we're going to say plus 8x, right? Now, what do the two numbers on top have in common? What do they have in common? What can we factor out of the two on top? X, right? What do the two on bottom have in common? 4, right?
No,
4, right? Positive 4. What do the two on left have in common?
3.
Nope.
Oh, no, sorry.
On the left, 2 left. 2x, right?
And then,
Tell me about the right.
negative 3.
-3, right? That's okay. So our claim is that the original factors into 2x minus 3, x plus 4. Okay? So this should we can quickly find our x-intercepts at this point. We see that the x-intercepts are 3 over 2 and negative 4. So here we'll say x equals 3 over 2 x equals -4. So now we're anticipating a parabola that opens up, crosses the x-axis at -4, and then crosses again at 3/2. So when is it above the x-axis? So again, we're anticipating some graph where here's our -4, here's the y-axis, here is our 3/2, and we're anticipating something that looks like this. All right. The question asks us, when is this above the x-axis? Now with this drawing, when is this drawing above the x-axis?
It's higher than
To the higher than,
-4 and 3/2.
okay, when it's to the right of 3/2 and to the left of -4. You see that? So it's above the x-axis from here and from here, right?
Yeah.
So that purple part,
To the right.
yeah, it's above the x-axis. So then in interval notation, we're going to say the far left, it goes down to -infinity, up to -4, and then we're going to combine that with 3/2 up to infinity, okay? And in this case, we got a bar, so we're going to put a bracket. A bar means a bracket, okay? So long story short, this should be the result. Not trivial. You're going to have to look at that. I'm going to try to shrink this down to size and clean it up just a little bit. Again, that was oversimplified and kind of quick. This is streamed. You do get a copy of this on YouTube, so you're going to have to do what you need to do. You can check it, but again, for quadratics, the easiest thing for me for quadratics, look at the graph. And once you get a sense of how it works, you work it and you start comparing that to the graph. To me, that's the simplest way to solve these, get these correct. I'm going to just check based on what they have. Yeah, we are out of time. Where's the solution? Choose a test value. There it is. -infinity to -4 union 3/2 to infinity. And notice the square bracket. That 4, we got to check that -4 though. They got a parentheses. My claim is that it should be a square bracket. Let's look at the -4 really quickly. So, -4. Yeah, the PowerPoint definitely has typos on occasion. I just want to plug it into the original. So really quickly, I know we're out of time for this section. I want to go to y equals the original. So I'm going to say the 2x squared plus 5x minus 12. When we plug in that -4, we should get 0. So I'm going to go to variables, y1. Now when x is -4, so I think that's a typo that they have on their part. Right here, that's supposed to be a square bracket. So I'm going to just square it up. I can't see why that wouldn't work. Let me look at it one more time. Yeah, it should work. So yeah, -4 is a 0. Okay, I think that's just a typo. They definitely have typos. Okay. Let me kind of scroll through really quickly. You can look at that on your own. This is an example, so just check it out. With these examples, anything that we don't work together, all these examples, you want to take the original, start from scratch, and make sure that you can arrive to the same conclusions. Like, don't take my word for it, because I make mistakes. The PowerPoint makes mistakes. You want to verify all of these results. So start with the original with minimal support as you can. See that you can arrive to the same conclusion. I'm going to leave this as an exercise. Okay, I'm going to leave that as an exercise. The rational inequality, that's a challenge. Okay, I'm going to leave that as an exercise for you to figure out. Okay, if anything is not clear, contact me via email. Basically, you're going to set to 0, get a common denominator. You want to isolate the fraction or the rational expression. Set it to 0, combine like terms, get a common denominator, all that jazz. It's a little bit extra, but you'll start to see it. Just follow a few examples, work it. If it's not clear, email me, okay? And I can do a dedicated video. I'm going to let that be. I'll let that be. That's going to be another example, so give it a go. If it's not clear, just contact me. Okay, but it's just, once you get past the first few steps, it's the same thing. Okay, so that's going to close out that section. I'm going to stop the stream. We're going to take a quick little break, and then we're going to use the remaining time for the next section. Okay, give me one moment.